All right, so question 3. Did anybody have questions on problem 3? All right, we're skipping 3. 3, Sarah? Yeah. Question 3 asks you to estimate the square root of 15. So I want to estimate the square root of 15. So if I'm trying to estimate the square root of 15, and it asks you to one decimal place, to your tenths place. If I'm trying to estimate the square root of 15, and you don't just use a calculator, what is the square root of 15 between 9 and 16? Very good. The square root of 9 is 3. And the square root of 15, I'm sorry, the square root of 16 is what? 4. What is this closer to, guys? Is it closer to 4 or is it closer to 3?
4.
It's closer to 4. How do I know that? 15 is closer to 16, right? So what would be a good first guess? 3.8. So if I do 3.8 and I square it, that gives us 14.44. Too high or too low? That's too low, right? What else can I guess? If 3.8 is too low, what would be a better guess? 3.9. If I do 3.9, that's 15.21. That's too high. So if 3.8 was too low and 3.9 was too high, Allison, what do you think? 3.88. .88 is going to give me about 15.05. Is that close enough? Yeah?
Isn't 3.9 in the range?
It's a little bit high, but just wait, we'll see. Is that close enough, guys? That's close enough, right? That's definitely close enough. So we can say that the square root of 15 is approximately 3 point what? 3.88. Now it wants us to round to the first decimal place. That means it wants us to know if we can round this number, this 8. Can we round that 8? And if I round that 8, then the square root of 15 is approximately what? So it's all about rounding for this one. Does that make sense, everybody? Any questions on that? No? Does anybody need to see question 4? Question 4. So there's a little trick to question 4. Question 4 is 12 and 1/4, and they want us to turn that into a decimal. What I want you guys to understand is that this is made up of almost 2 numbers. It's made up of the number 12 and the number what? 1/4. Do I want to turn both of them into decimals? I could just turn the fraction into a decimal. So all I'm going to do is I'm going to turn the 1/4 into a decimal. How do I turn 1/4 into a decimal, guys? I'm going to divide, right? What goes inside the house? And what goes outside? How many times does 4 go into 1? It doesn't, so I'm going to use my decimal point and add a 0. How many times does 4 go into 10? 2 times 8. I'm sorry, 2 times 4 is 8. Subtract both of them. 10 minus 8 is 2, and then I bring down a what?
0.
4 goes into 20 how many times?
5.
So what is 4? What is this? What is 1/4 as a decimal? Is 0.25, right? But my number is made out of 12 and 1/4. So how do I write 12 and 1/4 as a decimal? So check it out. The 12 is there, and the 0.25 is right there.
But I didn't do it differently because I did it different. I just got the right answer.
Yeah, that's fine. You could do it differently. Like you could have turned it into an improper first and then divided that way. But this is the easiest way. How many of you guys are kind of bummed that you missed this one? You guys understand it now?
I did it right, but then I put 8 instead of a 2.
Uh-oh. Are we okay? Question 5. Does anybody need question 5? Nobody needs question 5? We're good? You need question 5? Okay. Question 5. Choose true or false. For A, it says all decimals that don't end are irrational. What's a decimal that doesn't end? What do we call them? Repeating, right? We call them repeating. So 0.3 repeating that doesn't end, is that irrational or is that rational? That's rational, because how do we write that as a fraction? That's 1/3, right? So do all decimals that don't end, are they irrational? Girl. How'd you guys not do the back?
Because I don't look at the back.
So A is what?
False.
A is what, guys?
False.
A is false. Now B, it says all radical numbers are irrational. A lot of them are, aren't they? But are all of them irrational? Give me one radical number that is not irrational. What's an example of it being false? This is false. But why is this false? Somebody give me a rational number that is not irrational.
Not irrational.
Yeah, give me a radical number that is rational. No, 2 is the square root of 2 is irrational.
4.
The square root of 4. The square root of 4 is definitely a rational number. So that's rational. So that makes that one false. What else is another rational radical? Yeah, Avery? Square root of 9. Square root of 9 is also rational. Any questions on that? Are we good? Yeah? Does anybody need question 6? Question 6? Let's go over question 6. Do you guys prefer the board like I'm doing it right now? Yeah. Question 6 says, which of the following are true? For the first option, it says the square root of 14 is greater than pi. So I need to turn these into decimal forms. Pi is probably the easiest because we know that pi is around what? Pi is about 3.14, right? Now I need to turn the square root of 14 into a decimal. You had a question, Malachi?
Yeah, are you going to let us use calculators for the retake?
Yeah, just like you did on the regular test. But no work, no credit. So I need to estimate this. What is the square root of 14 between?
Square root of 9 and square root of 16.
What's it closer to?
Square root of 16.
So that means it's closer to what number? It's closer to 4, right? What would be a good first guess? 3.7. If I do 3.7 squared, that's 13.69. That's too low, right? What's another good guess? 3 point what? 3.75? 3.75 is 14.06. That's close enough. I'll allow that. So what's bigger, guys? 3.75 or 3.14? 3.75. So is this true or false? This is true. Is everybody okay with that? Max, you good? Yeah. What about for 2? It says 17 over 5 is less than the square root of 40. Again, I have to turn these into decimals. So 17 over 5. If I want to turn that into a decimal, what goes inside the house?
17.
And the 5 goes on the outside. 5 goes into 17 3 times. Subtract them, you get a 2 as a remainder. Put your decimal, bring down a 0. And does 5 go into 20, guys? 4 times. So when you subtract them, there you go. So 17 over 20 is what? I'm sorry, 17 over 5 is 3.4. Now I have to turn the square root of 40 into a, so I know that I have that decimal first, and then I need the square root of 40. What is the square root of 40 between? 49 and 36. Abigail, can you tell me what the square root of 36 and 49 are? Yep. That's okay. These are perfect squares. So what is the square root of 36? Help her out, guys. What is the square root of 36? 6. And then the square root of 49? 7. Okay. Remember, have that table. Okay. How many guys had a table in your notes and it helped? Okay. Always good to have that table. Now check it out. I'm not even going to have to estimate it because I know that the square root of 40 is between what? 2 numbers?
6 and 7.
So what's the smallest the square root of 40 can technically be? 6 point something, right? Is 6 point something going to be bigger than 3.4?
Yeah.
So is the square root, or I'm sorry, is 17 over 5, is that less than the square root of 40? This is also true. That is also true, guys. And the last question we had, or the last option, was the square root of 17 plus 8, all inside the square root, is greater than 20. This might have seemed confusing, but what is 17 plus 8? Okay, let's go with Max. What is 17 plus 8, dude?
25.
25. And then what is the square root of 25? So is 5 greater than 20, Max? 5 is greater than 20, so 5 is a bigger number than 20?
No.
It's not, right? So this is what, Max?
It's less than.
It's less than. So do I say that this is true or false? It's false. Very good. So which 2 options were true?
1 and 2.
1 and 2. Does everybody understand why 1 and 2 were true and why the third one was false? Are we okay, guys? Okay, let's does anybody have questions on question 7? No? Okay. What about question 8? Question 8, Alex? Yeah. So for question 8, it says compare the decimal forms of 2/5. So I'm going to compare 2/5 and 4/9. And they want to know how these are alike and how they are different. Some of you guys just answered the different part and not the alike part. Some of you guys just answered the alike part and not the different part. How are these alike, guys? Yes?
They're both rational numbers.
Very good. They're both rational numbers. Now, I don't want you to say, hey, they're both fractions. We can clearly see that they're both fractions. I want you to use more mathematical terms, okay? What did we learn this whole, 5 weeks that we've been here? Rational and what? Rational and irrational. So you should be very comfortable using that terminology. So how are they alike? just like Liliana said, they are both what?
Rational.
They are both rational. And how are they different? Let's go with Nathan. How are they different? How is 2/5 different from 4/9? One of them is repeating, one of them is terminating. You're absolutely right. Which one? Hold up, he's got this. 4/9 equals a repeating, and 2/5 is your terminating. Perfect, Nathan. Great job, dude. Does anybody want me to turn them into decimals so you see it? Are we okay? Turn them into decimals. Okay, so the 2/5, if I wanted to turn it into a decimal, I put the 2 inside the house, the 5 outside. The 5 does not go into 2, so I'm going to put my decimal point. And I'll add a 0. 5 does go into 20 though. It goes into it 4 times. 4 times 5 is 20. And then that subtracts. So 2/5 written as a decimal is 0.4. And that is terminating because it stops. Now 4/9, if I wanted to write that as a decimal, the 4 goes in, the 9 goes out. 9 does not go into 4, so again I'll add my decimal point. 9 does go into 40. How many times, guys?
4 times.
4 times. 4 times 9 is? Subtract them, I get a 4. Again, I have to bring down a 0. 9 goes into 40 4 times. What do you guys notice? It's repeating, right? So that's why that one is repeating. So even though they're both rationals, one of them is a terminating, one of them is repeating. Are we okay with that one, guys? We got about 15 minutes, guys, to cover a whole lot of this test. Does anybody need to see question 9? Question 9, okay. So question 9, first thing I'm going to do is I'm going to define the sets. I think that's what got you guys. If I'm talking about whole numbers, these are your whole numbers. Your whole numbers start at 0, then they go 0, 1, 2, 3, 4, and it goes on forever. Okay, those are your whole numbers. Then you have your integers. And the integers, they are like the whole numbers, but what do integers include? They include negative. Do they include negative decimals or negative non-decimal numbers? Very good. Thank you. So let's look at these guys. Which set has more numbers in it? Whole numbers or integers? Integers. So integers are a bigger set than whole numbers. Does that make sense, everybody? Yes, no? At least give me a nod. Malachi? We're good? Yeah? Okay. So integers are a bigger set than whole numbers. Then we have our rational. What do rational include, guys? And I'll put it under it. Do rational numbers include all of these? Like, for example, is -2 over 1 a rational number? It is, right? But also, what else is a rational? Decimals, right? So it also includes decimals and it also includes fractions. So what's a bigger set? Rational or integers? Which one has more numbers in it? Rational, right? So rational is bigger. Now the reason I put rational under it is because I'm going to put irrational over here and I'm going to put these side by side. I want you to notice something. What are my numbers that are irrational? Give me a number that's irrational, guys. Go ahead, Jonathan. Pi is irrational, so it definitely includes pi. What's another irrational number? Is the square root of, I don't know, let's go with the square root of 26. Is that rational or irrational? That's irrational. What about the square root of 2? Irrational. What about the negative square root of 2? That's irrational. I want you to notice something about our sets. When we look at whole numbers and integers, is there something that integers and whole numbers have in common? Do they have any numbers in common, guys? Yes? Which one, Emiliano? 0 and then it goes on, right? All those numbers are alike. What about integers and rational? Do they have anything in common? Negative whole numbers and whole numbers, right? Now, do rational and irrational have anything in common? They don't have anything in common. They are different sets. Whereas the sets before, they kind of build on each other. Rational and irrational are completely different sets. For example, do you guys remember the crayon analogy that I used? Okay, think of it as rational being crayons and irrational numbers, they're your colored pencils. So there's still colors, but they're completely different type of crayons or colored or utensils. Does that make sense? Okay, so and then we have our last one. What's our last one? Last one is our real numbers. And our real numbers, it's a mixture of all your rational and irrational. So I can put ... -2, the negative square root of 2, 0, 1/2, 1, pi, ... What do you guys notice about the real numbers? It includes what? Everything. It includes everything. So if somebody asks you, hey, which one of these sets is the biggest? What is the biggest? Which one's the smallest? Whole numbers are the smallest. Does that make sense, everybody? He's not wrong. He's right. So if you have a circle like this, and this is B, and this is A, what can I put for B? Like, give me an example of what I can put B for real, and what would A be? Did it matter at that point? It could be anything else, right? What if I put integers for B? What would I have to put for A? Whole. Can I put whole numbers for B? Why not? That's the what? That's the smallest set, so I wouldn't be able to put anything smaller unless they give me natural numbers, but they didn't. Okay, are we okay with that? Does 9 make a lot more sense now? Yeah? You wouldn't be able to put them next to each other. Like, you wouldn't be able to say B is rational and A is irrational because they're different sets. Like, remember what I said? One of them is crayons, one of them is colored pencils. They don't overlap, so you can't say one is bigger than the other, or that one belongs in the other one. Okay. So question 10. Did anybody have a question on question 10? Question 10. All right. So it says find an integer between the negative square root of 9 and 3/2. Again, I need to turn this into a decimal. So the negative, think of this as -1 times the square root of 9. We all know what the square root of 9 is because it's a perfect square. Let's go with Jonathan Marroquin. What is the square root of 9? So this is going to be -1 times 3. So the negative square root of 9 is what? -3. So I'm going to draw a number line. If I drew a number line, I have -3 on my left end, and then I have 3/2. What is 3/2 as a decimal, guys? 1.5. And that's on this end. Now it's asking for what? Integer. So you need to know your integers. Integers are, do we have any kind of decimals or fractions in integers? No. So what integers are between that? Give me one integer between -3 and 1.5. Go ahead.
-1.
-1 would definitely work. What's another one? -2 would work. What else? 1 would work. And last but not least? 0. If you gave me any of those, it would have been fine. Does that question make a lot more sense now? Allison? You can put all of them if you want, but you don't have to. Just one is good. Any other questions on that one? No? Okay, so on the next part of the test, I'm assuming you guys don't need help with the first one because that was just a definition. Are we okay with that one? Okay, what about the second one when we had to categorize them? Does anybody need to see number 2 for the categorizing? Okay, so if I'm trying to categorize, oh, this is question 2. So if I'm trying to categorize, I was given the following set: 1/2 pi square root of 2, the square root of 9, 3.14, and 1.5 with a repeating 2. Now, I need to categorize these as either rational or irrational. And I'm going to go step by step. 1/2 is what, guys?
Rational.
How come?
Because it's in the form of A over B.
Very good. It's A over B, where A and B are integers, right? And B is not equal to 0. Okay. What about pi?
Irrational.
How do we know?
Because
It's repeating and?
it doesn't have a pattern.
Exactly. There's repetition, but there's no pattern. Because you could have repeating numbers, and those are what?
Rational.
Those are rational. This does not repeat. This just goes on forever. So I think I said it repeats. It doesn't repeat. It just goes on forever without repetition. Okay, what about square root of 2? That's also irrational. I'm sorry, let me write it like this. Why is the square root of 2 irrational, guys? Again, if we were to try to find that, would we ever stop? If I was to try to find the exact number for the square root of 2, we would never stop because it goes on forever without any kind of repetition. What about the square root of 9? That one got a few people. Why is that rational? Square root of 9 is 3, right? And 3 is a rational number. What about 3.14?
Rational.
That's also rational. Even though that's the beginning of pi, is that actually pi? No, that's just a decimal that what? What kind of decimal is that? This is terminating. Thank you. And last but not least, we have 1.52 repeating with a repeating 2. What is that? That's also rational because it's got repetition in it. Does that make more sense, everybody? Yeah? Yes?
Are all repeating numbers like the last one on rational going to be rational?
They'll be rational. If they repeat, yeah, it's rational. Does anybody need to see 3a? 3a? Okay. So if a 3a was turned 0.28 into a fraction, and the way you do that is you let x equal 0.28. And I want to basically get rid of the decimal, so what would I have to multiply by? Both sides, right? A 100 times x is just going to be 100x. And then what's 100 times 0.25, guys? Or 0.28, I'm sorry. Just 28. And last but not least, I have to divide both sides by 100. If you left it like that, that would have been wrong because this can be reduced. What does this reduce to? What is it? 7 over 25? Does anybody need to see 3b? We're okay with 3b? What's up, Malachi?
I know we're running out of time, but I had a question like the last few.
The last one? Do you want me to do the last one instead?
Yeah.
Okay. So, 6 or 7? 7? What do you guys notice about the square root? Is there something outside of it? So how do I get rid of that negative 7, Brian? Add 7, very good. These are going to cancel. Leave me with the square root of 2x minus 3 equals what? Equals 3. And how do I get rid of the square root, guys? I square it. That gets rid of the square root, which is 2x minus 3. Equals what? Not 6. What is 3 squared? 9. And then I add 3 to both sides, which leaves me with 2x equals 12. And last but not least, divide both sides by, which gives me x equals 6.